Students, this is a video for the fifth lesson in the fifth unit, the unit on linear equations. This particular lesson is linear equations 1. We're going to be dealing with the specific key features that are in every linear equation, namely the slope and the y-intercept. We're going to get into that right now. For the lesson target, we're going to identify key features of linear functions and relate those features to their graphs. So we're looking at key features. Of course, those key features are going to be the slope and the y-intercept, linear functions, and relate those features to their graphs. So we're going to be taking those slopes and those y-intercepts and placing them on an xy coordinate grid. All right, the do now is based on the lesson from before, the fourth lesson, which was about horizontal and vertical lines. For each graph, identify the equation. And as a quick reminder, you might want to write down on your paper that mnemonic device that we use, which is VUX-HOI. I'm going to write it here. This will be useful to you. All right, pause the video, try this one out, and then see if you got it right. All right, we're starting off with whether they are vertical or horizontal lines, and then trying to figure out what that means for the equation. This one is a vertical line. It's going straight up and down. So that means we're dealing with x equals. That's the v and the x in VUX-HOI. V stands for vertical, and if it's a vertical line, it's got x equals as its equation. This is a horizontal line. It's going straight across from left to right. So since it's horizontal, we're saying y equals. That's the HOI part of VUX-HOI. If it's a horizontal line, that means it is a y equals line. Same thing over here, vertical line, so x equals, VUX is v for vertical, x for x equals. The u and the o, of course, stand for undefined slope and zero slope. That's the two different types of slope that you could see for horizontal or vertical lines. Okay, but it's not asking for what the slopes are for these different lines. It's just asking for what the equation is. In every case, we're just going to find where the equation hits the axis, whether the x-axis or the y-axis, identify that number, and that number is the number that goes into the equation. So this one intersects the x-axis at 3, so the answer is x is equal to 3. For this one, it intersects the y-axis at 4, so y equals 4. And for this one, the x-axis is intercepted at -5 right here, so x equals -5. Easy as that. All right, moving on. The next part says solutions to linear equations. We're going to be taking a look at the solutions and what that means for the graph. Now keep in mind that every time we make a graph, we're identifying several coordinate points. Right? We're putting points on the graph and then connecting those points to make a line. Each of the points represents one solution to the equation. So in this particular case, the equation is y equals 2x minus 3. What we're going to do is we're going to find solutions using those x values that we talked about in a previous lesson. We're going to find solutions for this equation and then graph those solutions on the graph. When we graph all of the solutions all at once, they form a straight line, and that line represents every single possible solution, not just the points that we graphed, but solutions in between, solutions outside of that, etc. So let's fill in these boxes with the numbers that we know from a previous lesson. Of course, those numbers are -2, -1, 0, 1, and 2. That was from the lesson on the 5 number tables. And in every one of these rows, I'm simply going to take the equation. I'm going to substitute in the given x value for x, and then I'm going to rewrite it and try to find what y is equal to. For example, for this first row, y equals 2 times -2 minus 3. I substituted -2 in for x, because for this case, x is equal to -2. Solving this, I get 2 times -2, which is -4, minus 3 is, of course, -7. Gives us that the point -2, which is the x value, and -7, which is the y value, they combine to be a solution to this equation. In other words, if you put in -2 in for x and -7 in for y, the two sides of the equation are equal. They balance each other out. Okay. The reason that we're identifying that is because we're trying to find solutions to equations. That's the whole idea of algebra, right? Finding solutions to equations. Now, the nice thing about a line is once we make the line, that will tell us every single possible solution to this equation. Let's fill out the rest of the rows. We find all of these points are also solutions. So if I put in -2 for x and -7 for y, this equation is true. If I put in 0 for x and -3 for y, the equation is true. If I put in 2 and 1 for x and y respectively, this equation is true. So now what I'm going to do is I'm going to graph them on the the coordinate grid at right. If I can, keep in mind that -2, -7, I can't graph it. But if I can graph it, I'll do it. So here's how it looks. And not only can you see that each and every one of these points represents a solution to the equation, but you can see that they are all in this pattern, this like increasing pattern here. And what I can do is connect those points with a straight line. Notice right away that one of the key features that I can identify, let's grab a highlighter here, one of the key features that I can identify is where this line intersects with the y-axis. That's that point there at -3. So this line rather, is only going to touch this y-axis once. It's only going to intersect the y-axis once. And that point is at -3. That's one of the key features of this graph, where it touches the y-axis, or where it intersects or intercepts the y-axis. We call this point the y-intercept. Okay, so there's our y-intercept labeled. There's another piece of information, there's another key feature of this graph and of all linear equations, and that's the pattern that it follows from one point to the next point. And you'll see that in this particular line, from this point to the next point to the next point, every single time I'm following the same pattern. I'm going upwards by 2 and to the right by 1. So up 2 over 1. It's not just from the y-intercept to the next point, it's really from any point on this line to any other point. As you can see from these arrows, it's always up 2, right 1. So since that pattern is the same, it's a constant pattern, we're referring to this line as having a constant slope. That slope is just all the up values divided by all the right values. In other words, my rise divided by run is 2 over 1, which is equal to 2. So if I were to summarize the key features here, I have 2 as my slope and -3 as my y-intercept. And conveniently, we actually have this information already encoded into the equation. If I look at the equation, it says y equals, that first number here, the number that's a coefficient of x multiplied by x, that number is 2. And it just so happens that the slope is also 2. And similarly, the number that's by itself, a constant term in the equation, is -3. And it just so happens the y-intercept is also -3. So the information that's given to you in the equation is the same as the key features. The information in the equation tells you the slope, and it tells you the y-intercept, the slope being 2, and the y-intercept being -3. That information is given to you in the equation, which means if I give you the equation of a line, you can graph the line. And if I give you the graph of a line, you can write the equation. That ability to translate back and forth as part of our learning target, identifying the key features and using them on graphs. All right, the information that I just gave you is here. Let's fill out briefly what these blanks are supposed to be. Now this is an example of a linear equation. This is the slope-intercept form of a linear equation without the numbers plugged into it. A linear equation is just an equation whose solutions are a straight line on the coordinate plane. We just saw one on the previous example. Here's another one. This has a similar slope. The y-intercept here is -1, which means the line intersects the y-axis at -1. So all of the points along this line are solutions to this equation. And this form is called slope-intercept form, y equals mx plus b, because if it's written in this form, the slope, or m, and the y-intercept, or b, are readily available there. You can find them right from the equation. So when a linear equation is written in this form, we can use that information to graph the line. That's the purpose of this lesson here. So in the check for understanding, I gave you a couple of equations, and now what your job is to identify what the slope and the y-intercept are, then graph the equation. I'm going to do the first one with you, but the other two we're going to do in class. So pause the video, try this one out, and then see if you got it right. So first of all, let's identify the slope and the y-intercept. The slope is -3, not -3x, just -3. Slope is a value, a numerical value. It doesn't involve variables. And the y-intercept is 4. So my first thing that I'm going to do is identify where on the graph that 4 is, which is here on the y-axis. So I'm going to put a point there. Typically, when I'm looking at slope and it's not a fraction, it's typically useful for me to turn it into a fraction. So I'm going to call this -3 divided by 1. Any integer can be written as that same number divided by 1, and it's equivalent. So -3 over 1 means my rise is -3. In other words, from this point, I'm going to go down by 3. And my run is 1, which means I'm always going to run to the right, regardless of the sign of the slope. So I've gone down by 3, so I'm going to run to the right 1. So that would be where the next point lies. this basically tells me go downwards by 3 and go to the right by 1 from the y-intercept to get to the next point. It's kind of a, follow these instructions. So here's the next point. See, I've gone down by 3 and over by 1 to get to this point. Now, in order to get to the next point, I'm going to follow the same exact pattern. Down by 3, over by 1. So down by 3 and over by 1. Down by 3, over by 1, etc. I have the points all laid out. I'm going to connect them all with a straight line. Notice that this line extends to the edges of the graph, and there are arrows at the ends representing the fact that these solutions continue going forever in this direction and also continue forever in this direction. The last thing I have to include on my line is a label. We label it using the equation. So let's write that in here. Correct line linear graph has arrows, is extended to the edges of the graph, and also includes the label. Again, we're going to do the rest of these in class. All right, so rewriting in slope-intercept form, sometimes the equation will be given to you, and the equation won't be written in slope-intercept form. It won't say y equals mx plus b. Luckily, all we have to do to the equation is rewrite it by solving it for y. If you remember from the y equals mx plus b form that we talked about before, it is solved for y. The y is by itself, so all we need is for that to be the case. So for this first example, it says graph the line whose equation is 3y equals 4x minus 15. All we need is to get that y isolated. So here's how it looks. From the original equation, I noticed that in order to get y by itself, I needed to divide both sides by 3. So I divided both sides by 3, keeping in mind that I'm dividing each and every term on this right-hand side by 3. So 4 divided by 3 just gives us a fraction. That's okay. Slope is okay to be a fraction. Negative 15 over 3 is negative 5, and then 3 divided by 3, those eliminate. So all I'm left with is y on the left-hand side. Now that I have this solved in slope-intercept form, I can identify the slope and the y-intercept fairly easily. My slope is 4/3, my y-intercept is negative 5. Now keep in mind, the original form of the equation, I didn't know that. I didn't know that 4/3 was my slope and negative 5 was my y-intercept. I had to rewrite it in slope-intercept form. Using that information, take a look at the other equation, 9x minus 6y equals 18. Let's try to solve this for y. In other words, rewrite it in slope-intercept form. The first thing I saw was that y is on that left-hand side. In order to get that y by itself, I'm going to remove the 9x first by subtracting it from both sides. It eliminates on the left-hand side, and 18 minus 9x, they're not like terms, and I do want my x term to be at the front. So I'm going to put negative 9x at the front, and this is a positive 18, so I'm going to keep it as positive or plus 18. The next thing I have to do is get the y by itself by dividing by negative 6. That division goes down like this. These eliminate the negative 6's. Negative 9 divided by negative 6, of course, gives us 3/2 when we simplify, and then 18 over negative 6 is negative 3. So I can identify my slope and my y-intercept as 3/2 and negative 3, respectively. Again, I could not get that from the original version of the equation, but once I write it as slope-intercept form, it's an easy thing to identify. All right, so the next thing that we're going to do is the check for understanding number 2. Again, I am going to do this first one with you, and then you're going to try the other two in class. So here's y minus 3x equals 10. Let's pause the video, try this one out, and then see if you got it right. For this first one, I knew that negative 3x was on the left-hand side. I need to get it to the right-hand side, so I added 3x to both sides. Keep in mind that 10 and 3x are not like terms, so I can't combine them. And I know that 3x has an x on it, so I want that to be first. That's in standard form, right? X is first, numbers second. So positive 3x goes first. The 10 is a positive value, so it becomes plus 10. So my slope is 3 and y-intercept is 10. Make sure that when you're doing letters B and C, you write down slope and y-intercept like this. Don't just write down the correct equation. Moving on to linear equations to graphs. Let's say I give you a graph and you want to write the linear equation from it. The first thing you need to do when you're looking at the graph is to identify its key features, and then you can take those key features and turn them into the equation. So it says here, first looking at the graph right, the y-intercept is at positive 3. You can tell because it intersects that y-axis at positive 3. So that means one of its key features is b equals 3, or the y-intercept is equal to 3. And then from this point to the next point, I put the dot here so you can see it very clearly. From this point to the next point, we just have to count the boxes to see how far we went down and how far we went over. See, I drew in those blue lines to help you count the negative 4 down and 5 over. Another way that you can do it is look at the points. and say, well, from the y value of 3 to the y value of -1, I went down by 4, and then from 0 to 5, I went upwards by 5. We're going to be talking about that a little bit more extensively in the second linear equations lesson, which is linear equations 2. So you are able to figure out that the slope is -4 divided by 5. So what we do is we take m and b, substitute them into the equation, and for m we put in -4/5, and for b we put in 3. All right, let's take a look at the check for understanding. Again, I'm only going to do this one with you. I'm not going to do the other ones. So go ahead and pause the video, try this out, and then see if you get it right. Here we can see that the slope of the y-intercept is at -3. And we can also see that I've gone down by 1 and over by 5. So my slope is -1/5. So I can put that together, slope and y-intercept, into slope-intercept form. It looks like this. Here's how it looks written out, -1/5 x minus 3. All right, the next page is the problem set, and of course we're not going to do that together, so that means this is the end of the video. So this was the 5th lesson in Unit 5. This is all about linear equations. We're going to do another lesson tomorrow, finishing up the linear equations concepts. All right, folks, good luck studying.